Now, before we dig into different physical properties of organic compounds, let's first review the three intermolecular forces that determine several physical properties. Okay, so first, intermolecular forces is one of the key concepts that students must grasp in both Unit 1-2 and 3-4 chemistry. Okay, so VCA also continuously asks relevant questions about it. First of all, many students get confused with the term inter and intra. Well, in Unit 3-4, we mostly focus on inter, that is, attraction between or among molecules, okay, between two molecules, not within a molecule. So if you think you've got limited bandwidth, then forget about intra from now on, okay, just inter. There are three intermolecular forces: hydrogen bonding, dipole-dipole attraction, dispersion forces. Nothing else in VCE chemistry is intermolecular forces anymore, okay? Now, hydrogen bond, as the name indicates, hydrogen bond must involve hydrogen. However, how involved it needs to be? Well, the hydrogen that could form hydrogen bond must satisfy two criteria, okay? And the first criteria is where students mostly forgotten. Okay, so the hydrogen bond the hydrogen that is able to form a hydrogen bond must itself be covalently bonded to NOF themselves. That is to say that within that molecule, the hydrogen must be connected to N or O or F. Okay, so those kind of hydrogens, when there is another NOF in neighboring environment that attracts it, forms hydrogen bond. Okay, so if we look at a molecule as a family, only when there is NOF within the family household bonded to the hydrogen, then that particular hydrogen can form hydrogen bond with the NOF in a neighboring household. Okay, two houses, but within the house, there must be NOF as well and bonded to hydrogen. Okay, so hydrogen bond is the strongest of all three types of intermolecular forces. And dipole-dipole attraction, that attraction forms between polar molecules. The partial positive end of the molecule is attracted to the partial negative end of a molecule. So the more polar the molecule, the stronger the attraction. Note that this is not a hydrogen bond here, although it does involve hydrogen. Okay, so some students would wonder, isn't hydrogen bond also dipole attraction? Or if a molecule has hydrogen bond, can they also form dipole-dipole attraction as well? The answer is yes. Only that hydrogen bond is too strong compared to dipole-dipole attraction. It's 10 times stronger. So it often overshadows the dipole attraction from the rest of the molecule. Dispersion forces. Dispersion forces exists because of the instantaneous dipole formed out of the movement of the electrons in the molecule. The bigger the molecule, or the more atom there is in it to form that instantaneous dipole, then the stronger the dispersion forces. Now, due to the nature of the dispersion forces, it exists in all molecules. It's like the background noise of intermolecular forces. Okay, so let's check if you have understood hydrogen bonding in this case. Okay, so now the three cases, the dashed line indicates that it is an intermolecular force. The question is, which ones of the following is a hydrogen bond? If it is not a hydrogen bond, in some cases, what is it? Which intermolecular attraction it is? Okay,